Welcome. In this video I'm going to show you how you can perform a McNemar test as a post-hoc test for a Bowker test. I'm using Python 3 and specifically in Jupyter Lab. So after a McNemar Bowker test, or simply Bowker test, we know that the changes are or aren't symmetrical. If you want to know how to perform a Bowker test, I have a separate video on that. We then might want to know if it's significant which two categories are significantly different, or where actually that switch took place. One option to do this is to create a cross table of each possible pair and then perform a McNemar test on each. We do then also have to adjust for multiple testing, and that can be done by using, for example, a bonferroni method, but there are a lot of different methods out there. I've not been able to find a package that can actually do this as a post-hoc test. There are packages to do a McNemar test on a single 2x2 table, but not to actually do that pairwise in a run. So we need a little bit of code. To show you how I've done this, I'll use an example. The example I load is a pandas data frame, and to install pandas, if you've never used it before, ! pip install pandas. That goes for most packages. If that doesn't work, just do a quick Google search on how to install a particular package. I can then load the package, import pandas, and I'm going to abbreviate it, therefore I have the as PD. I can then use the read CSV to load my data and use the head to show the first 5 records. So people could choose between brands A, B and C, and afterwards also between brands A, B and C, and we might be interested if any changes took place, if people for example switch from brand A to brand B. The two categories for the two variables should be the same, so the number of categories. So it doesn't matter if I set my categories to be before or to the after. It should be the same, and it gives me brands A, B and C. So if I change this to after, it should give me the exact same result. I now can select any two categories. I can do this one by one. So I first select 0, so that's brand A, and then a second selection brand B, so I'm going to compare A with B. And let's see, so those are now selected, and that means from my data I need to select all the records where the category, the before was brand A or brand B, and also the ones that had brand A or B in the before. So that's where this comes in, every time all 4 possible combinations, and that gives me a new data frame where only I have brand A or B in here, and after also brand A or B. I can then use the McNemar test, and the McNemar test is available in the cross tab of ResearchPy, so I'm going to load in ResearchPy and specifically the cross tab function. I can then use the cross tab function itself, give it the 2 fields that I'm interested in, specify that I want to use a McNemar test. I can opt to have the exact or an approximate, and I can opt to do a continuity correction as either true or false. It will actually return the cross table of that comparison and the results, and that's the one I'm mainly interested in. As you can see, the results are in a pandas data frame. I'm not so interested at Kramer's phi at the moment. I'm more interested in these two. This is the statistic that's actually used, the chi-square value, and the p-value would suggest that the changes were not significant if we're using a 0.05 threshold. Usually anything below that threshold would then be considered significant. So in this case, for this, just missed the boat. A cross table is also available, and we can also make that ourselves. So we can simply say, well, I want to see a cross tab, and that gives you the cross table, and it should be the same as actually this cross table I've already stored here. We can load the stats models test for this as well, and then we can load and print the results, and as you can see, the exact same results as we had earlier up here. So both packages give us similar results. We do need to do this for all possible pairs. Now luckily I only have 3 categories, so that's 3, that's in total I think, yeah, 6 options. And you can actually calculate the number of tests that you will perform by doing the number of categories that you have multiplied by the number of categories you have minus 1 and then divide over 2. So in my case it's actually going to be only 3. Brand A with brand B, brand A with brand C, and brand B versus brand C. So it's 3, not 6. With len I can get the number of categories that I have. The results I want to see in a nice pandas data frame, so I already set up the columns for an empty one. And then I simply go over all of my categories for I. So the first one I'm picking, I arranged it from 0 to k minus 1 because I need to go one lower than the amount I have, so that the other one that I'm picking always starts at one higher than the previous one and runs all the way to the last one. So my first selected is then I and the second one is J. And then I simply repeat the exact same code as above. And I also add the bonferroni correction. So what you do is you take the regular p-value, the unadjusted one, and multiply it with the number of pairwise comparisons that you're doing. That might push it over the 1, and the p-value cannot be bigger than 1, so if it's bigger than 1, the adjusted one, just set it to 1. And that gives then this nice result, hopefully. So let's see if that works. Give it a bit of time. And here we have the results. And as you can see, brand A to B, the same result. Adjusted, it's clearly not significant, also not significant, and also not statistically significant. So they're all above 0.05, so none of them were significant. And that's because of the inflation, because of the multiple comparison. So sometimes you can have that the overall test, in this case the Bowker test, is significant, but then in your post-hoc there is non-significant because you have to adjust for multiple testing. I made all this code into one little function so that I don't have to repeat all these steps, and then I can just load in any data frame, select the 2 columns of interest, and then it gives me those results. I'll leave a link in the description of the video below to this Jupyter notebook, so you can download it and look at that code yourself and perhaps reuse my function. Please give credit where credit's due. And I hope this video was what you're looking for and it was helpful. Thank you for watching.